So the topic of today's webinar is the CAN automation device profile 443, the device profile for SIIS level 2 devices. My name is Reiner Zitzmann. I'm the general manager of CAN and Automation, and I'm going to guide you through this webinar. I hold a degree in electrical engineering from the University Erlangen-Nuremberg. I've been appointed as a general manager of CAN Automation GmbH in the year 2017. And I am also managing the CAN Automation office. CAN Automation GmbH is a 100% daughter company of the CAN Automation Association, which maintains the CAN protocol, promotes CAN, and so on. So I represent CAN and Automation, also in international standardization on IC level, CEN level, in the corresponding mirror groups. And furthermore, I attended from CAN and Automation, the working group for Subsea instruments. So I took also part in the development of CiA 443. Furthermore, I have long experience in presenting on conferences. For example, last week there had been the Embedded World Conference, where I was active as session chair or as speaker. Yeah, briefly to CAN and Automation. If you are not very familiar with CAN and Automation, who is CAN and Automation? Why are we organizing something like we're doing at the moment, like these webinars? So CAN and Automation, the association, is the international users and manufacturers group that develops and supports CANopen and other CAN-based higher layer protocols. The non-profit group was founded in 1992 to provide CAN-based technical product and marketing information. The association fosters the image of the CAN technology and provides a path to the future We are developing next generations of CAN, such as a CAN-FD, which is currently put in service into normal passenger cars by Volkswagen, for example, or the next generation of CAN, the CAN XL, which is currently under development in working groups at CAN and Automation. So I don't know exactly where you're residing at the moment. So in general, if you have the possibilities to ask questions or to overcome challenges that you may have in your projects, you are very welcome to come to CAN and Automation, to call CAN and Automation, to place your questions there. And you see here where CAN and Automation is located. We are located in Nuremberg. It's in the south of Germany. And of course, if you are not here in Germany, typically there take place Embedded World Fair or SBS, where many of our CAN Automation members are attending. And so it's CAN Automation and discuss also that challenge in our office. Of course, in times of Corona pandemic, that's not that easy. So for these cases, we have also the possibility to discuss via phone, via email, via web meetings, your issues, so that we can assist you to overcome the CAN-based challenges. So this is one of the main objectives of CAN and Automation, to assist people in using CAN to do social networking, to bring people together so that we can easily put our CAN-based applications into service. Then you see that CAN has been in use for a long time, but it's still very attractive for many companies. You see here the development of CAN Automation members. So we have this year the highest amount of CAN Automation members with 703 member companies, paying member companies. So you see for many companies, it's still very attractive using CAN, and furthermore, being member of the social network provided by CAN and Automation. You see here some brief milestones about CAN and Automation. CAN Automation had been funded by Berkhoff, ESD, Geyser, GIN, LP Electronic, MEN Technology Partnership, and Mr. Holger Seltwanger. And as I already said, they have the objective to promote CAN. Therefore, they published a magazine, the CAN newsletter. and presented CAN-based solutions on fairs. For example, the first one, the Interkammer in Düsseldorf. And you may know the development of CAN had been a rather German or a Middle European topic, but we don't want to limit CAN to this geographical region. We promote CAN worldwide. So when it is possible and not blocked by Corona, then we are organizing seminars, trainings, and so on, interoperability tests all over the world, not only in Germany, but we come all the US, to Asia, Japan, China, and so on. So we try to assist the CAN users all over the world. In addition to that, we offer also a neutral ground for companies to meet together and to discuss CAN-related issues, to develop harmonized solutions, so CAN automation specifications. And you see here, we developed in 1992 an idea how to set up a CAN physical layer for general purpose applications, then how to use the CAN frames, the first application layer. And you see here since 1994, and this is already relevant for our topic, we are maintaining the CANopen specification. One specific mean to use the CAN frames and to communicate information in a harmonized way via the CAN. So we are maintaining the CANopen protocol, and we do further developments. And we will see also during the session that CANopen defines several communication services, that CANopen allows setting up several communication coherences between the devices. And CANopen provides us also with a database, but not necessarily with a harmonized data content. The data content is typically added by so-called CANopen device profiles, and one of these device profiles is a device profile for Subsea instruments, the device profile CiA 443. And you see here in this slide that the first release of the device profile for CANopen device profile CiA 443 was in 2004. And in 2011, we released the version 2.0. And currently we have the version 3.0 released in September 2014. In the meantime, there on an international CAN conference, some representatives from Bosch have presented CANFD. CANFD has a higher data throughput compared to classical CAN. And we said, okay, with CANFD, we have new options, and with these options, we have to deal with also from a CANopen perspective, and therefore we updated CANopen to be able to deal with CANFD. This had been released in 2017, and this was the CANopen FD provided in CiA document CiA 1301. And as we have now an updated CANopen, and as 2014, where we released the last Subsea specification, there are maybe additional feature requests for Subsea instrument networking. There is CANopen FD. Do we like to make use of this? And summing all this up, we said, okay, it may make sense to restart the interest group for Subsea instruments. So if you are interested in joining this project, you can do this also as a guest, also for the moment free of charge. Then I really invite you to the next meeting. When the next meeting is, you will see on our webpage, and you can join it rather easily via the internet. And you can join this, make your feature requests, and double check whether attending this group could be rather beneficial for you. So you see this here. CAN and automation organized its technical group work in so-called technical groups, interest groups, one for CANopen, for CANopen FD. And we have here a very interesting one for you. It's that one for the profiles. So as we are maintaining different higher layer protocols at CAN and automation, CANopen, CANopen FD, J9039, it is of interest to say, okay, we want to have one way to organize the data And then this way of organizing the data, of having data in a harmonized resolution, data type as IONET and so on, this we want to map on the different communication technologies. And we have here one group, it's the Subsea group. I hope you can read it. The green letters on the green background is not the best way to emphasize something, but nevertheless, I hope you can read it. It's the Subsea group meeting next time, I think in April. And then we are discussing the latest feature requests and where to update the document CiA 443. So it's a good moment if you have some feature requests to step in, learn how the CiA 443 is working, and submit your feature requests. An interesting point also for the CiA 443 group is that they are organizing so-called plug fests. So conformance testing is one issue that okay, I have implemented my CANopen device in the intended way according to the CANopen specification, but it is more of interest that I'm interoperable with my device to other devices from other companies, even if it's not 100% CANopen, but I can work with other devices together. And in the past, the SIIS group organized in regular time distances so-called plug fests, interoperability tests, where companies from all over the world came together, attached their devices to the very same CAN network, and double-checked whether they can run together, whether they are interoperable, and whether a host controller can recognize the devices and can assemble from these devices a proper working Subsea control network. So very beneficial things in the past, and maybe we can reinitiate these activities also in the future now. Furthermore, CAN Automation is offering some kind of marketing. We haven't done this for Subsea so much because it was not necessary. All the relevant actors had been present in our working group, so this had not been very necessary in the past. Maybe we are doing some marketing activities in the future, but this is at the moment not on the roadmap. So summing up, CAN and automation is mainly working with specifications, is looking how can we give CAN-based devices a certain degree of plug-and-play capability in CAN-based networking, in CAN-based applications. So therefore, we develop these specifications oriented to the physical layer, data link layer, higher layers. What about security, redundancy, and all these things we are considering? Provide you a solution, and maybe it's applicable. We are doing some marketing, follow our newsletter for latest developments and activities, our email services, product guide, brochures, and on the other hand, we do some technical work, for example, conformance testing, plug fests, interoperability testing, or some consultancy services. We organize from time to time also an international CAN conference. This international CAN conference, the next edition is a pure online edition, and you will see which kind of information our experts are sharing. The next edition, the 17th one, is planned for June the 14th to the 17th. We will, in the surroundings, organize also open SIG meetings, for example, also one open meeting for non-members of the SIS group. And then we will discuss also here your feature requests. So maybe this is something you should remember. Furthermore, the proceedings are already available and details are regularly updated at www.can-cia.org/ICC. We provide also with some publications. I think you can see by yourself the newsletter magazine, our email services webpage. So here you will get everything, and the most valuable thing, if you are not CAN Automation member yet, access to all documents, including CiA 443 and all the accompanying documents that are relevant for implementing CiA 443, and I will mention during my webinar today. Okay, so much with regard to CAN and automation for the moment. So if you have some questions, you can ask them afterwards in the Q&A session, or by using the chat functionality. As I've said, I will consider it. Now let's come to the core topic, the CiA 443 CANopen device profile for SIIS level 2 devices. So we are talking about Subsea instrumentation interface standardization, or just abbreviated SIIS. This had been established in 2003, the SIIS joint industry project, so the SIIS JIP, and specifies communication protocols between a subsea control module and subsea sensors. More than 25 member companies from control system suppliers, instrument suppliers, and operators took part in this initiative. And they defined data exchange in subsea instrument control applications in 3 hierarchical levels. They considered the level 1, the analog devices, the digital serial devices, and the Ethernet TCP IP-based devices. So this means we have this kind of application. We have the top level controllers. They are up on the sea, and then we have a downlink to the bottom of the sea here, where we have our SIIS level 2 controller, and we have then our sensors, and they may have some additional sensors connected via analog connections. So you see here our levels. We have the level 3, the Ethernet-based network. We have the level 2, the CANopen network, and we have then a level 3, the analog devices, connecting some metering chambers, metering devices directly via 20 milliampere, for example. So having this in mind, we see here our 3 levels as they had been defined on the SIIS, and for further details, you can also browse the SIIS website at www.sis-jip.com, and you can review there the levels which we are considering. As I've said, the analog devices in level 1. These devices are 4 to 20 milliampere sensors, 2 wire loop powered analog output sensing devices. So rather simple sensors. Then we have the more complex ones, the digital serial devices. These devices are relatively complex sensors or instruments which have a digital connection to the control system in a star connection style typically. They can also include downable characteristics, and most importantly, described as having open standard characteristics. These can be can be distributed topology. The communication protocol uses CANopen according to CiA 443 or an ISO 11898-3 fault-tolerant physical layer. And finally, we have our level 3, the Ethernet TCP IP devices. These devices are used with intelligent seabed devices where direct communication access is required between the ISD, the intelligent seabed device, surface application system, and the intelligent sea-based devices. So you see, once again, we have our 3 levels: analog devices, digital serial devices, and Ethernet TCP IP-based devices. And in our document now, CiA 443 SIIS level 2 devices, this level 2 refers to this level 2 here, and we are talking about these digital serial devices linked together via a CANopen network according to CiA 443, based on a physical layer according to ISO 11898-3. So I will say something to this later on in this webinar. So we have now here our application. We have our SIIS level 2 application master, and this application master is collecting the data from the subsea instruments, temperature sensors, pressure sensors, valve, multi-phase meters, send meters, and so on. So This is our application that we have in mind, and for the communication, we are using here CANopen and CANopen in a specific flavor according to CiA 443. So what is CANopen? CANopen is a specific way of communicating in a CAN-based network. So CANopen, a so-called CAN-based higher layer protocol, provides us with a device architecture, a device model, explaining where do I have my device internal database, where do I find my data which has been generated in the SIIS application, and how do I use the CAN frames for communicating this data. So all the CANopen basics are defined in the basic CANopen document CiA 301. This is the basic document. But CANopen is not a monolithic document, but is an entire profile family. CiA 301 just defines the basic CANopen functionality, but when we are doing CANopen in a SIIS level 2 environment, we have further documents to consider. For example, we will learn CANopen assigns to every device in the network a unique node ID. How we do this in SIIS level 2 applications, it's written in the document CiA 305, the layer setting services. Then how does our application data look like? This is a document CiA 443. So here is the data defined, which is then communicated with the basic means described in CiA 301. Then how is a SIIS application started up? By an application master application. This is written in document CiA 302 and referenced then in our CiA 443 document. And furthermore, we have learned that we may want to have access from the level 3 to the level 2 and from Ethernet to CANopen embedded networks. And exactly this use case is described in the document 309. So therefore, I highlighted these documents. We are starting with 443. 443 is defining the data communicated with CANopen. CANopen is defined in 301. And then we have there some extensions that we can consider. All the documents provided by CAN Automation are available here on our homepage at groups/specifications. Just log in the website and you can download all our documents. Just for explaining what CAN and Automation is doing when we are defining a CANopen device profile, we are defining the data content that is transferred via so-called CANopen communication objects. Communication objects for establishing a point-to-point communication, broadcast communication, multicast communication in a confirmed way, in an unconfirmed way, doing network management, communicating diagnostic data, and so on. And the device profile, such as 443, defines the application data, and CANopen provides you then the mean to communicate this application data in whatever suitable communication coherence. And in a CANopen network, we have such a layer structure. We have, of course, lower layers, such as a data link layer, a physical layer. Every CANopen communication object has to be transferred on the data link layer level in form of CAN frames via the bus, typically several CAN frames, maybe sometimes one CAN frame is sufficient. And every CAN frame is transferred bit by bit on the CAN physical layer. And for all these layers, we are getting specifications, additional specifications in CiA 443 and CiA 301, the basic CANopen specification. So please have always this slide in mind when we're talking about CANopen and CiA 443. We are always in this layered network architecture. So let's have a look on the physical layer for subsea instruments. And here we have a certain exceptional decision by the SIIS group. The SIIS group said we are not using the ISO 11898-2, which is, of course, the mass market for CAN, but we deviate from this and we want to use the ISO 11898-3, the fault-tolerant transceiver. CANopen does not close the door to do so. CANopen allows you doing so. And this means they have opted for this specific transceiver. They can use all the benefits, which we are going to discuss soon. But this means also they enter a niche market. It's not that simple to use average tools here in this environment. You always need a kind of adapter to make your tooling running in the environment of CiA 443, as they're using a specific transceiver which differs with its characteristics from the transceiver ISO 11898-2. With regard to the physical layer, we have also to discuss the bit timing. The bit timing is provided in ISO 11898-1. Additional definitions I find in CiA 301, the basic CANopen document, and finally in CiA 443. So CiA 443 does the bit timing definition more or less based on the input from CANopen basic document. And finally, we got some ideas with regard to connector pin assignment and cabling. We have the ISO 11898-3 transceiver, and we have here one specific. The ISO 11898-3 transceiver is capable to react on errors in the lowest layer in the physical layer. And therefore, this transceiver is also called the fault-tolerant transceiver, as in case one of the lines, the CAN high line or the CAN low line, is dealing with some errors, we can switch from a differential transmission to a single wire transmission, and maybe with reduced performance, we can still keep the communication link running and exchange data. So we see here on this next slide, we have an open network. On the past slide, you saw the nodes are directly terminated, and we have open wires here on the trunk line. We have a CAN high line and a CAN low line, and the fault-tolerant transceiver is capable to detect one of these errors: CAN high line, CAN low line, interrupted, shorted to battery voltage, to ground. So in all these error cases, we have the ability to keep the communication link running. This is the advantage, and this was why the oil and gas industry said, well, we want to be also on the safe side on this lowest layer, on this physical layer, and therefore we are looking for this niche market and support this kind of physical layer. Because our instrument is very expensive, it's down in the deep sea, there is not the possibility that a system integrator is going down and fixing something. And on the other hand, there's a certain degree of probability that some salty water comes into the device and corrodates one of these pins, and then as a consequence, the communication could not be established anymore. But due to the capabilities of the fault-tolerant transceiver, we can switch to a single wire transmission, and the communication link is still available. The big disadvantage is that this ISO 11898-3 capability is achieved by using different voltage levels compared to those from the high-speed transceiver. We see here the dominant bit is represented at -5 volt. We have the CAN high line at 5 volt, the CAN low, the CAN high line at 0 volt, the CAN low line at 5 volt, and we have the recessive bit with 2.2 volt nominal, the CAN high line at 3.6, and the CAN low line at 1.4 volt. So we see we deviate from those voltage levels that we have in the high-speed transceiver, and this means a device based on ISO 11898-3 can't be operated in an environment with high-speed transceivers. This I have to consider. So in our SIIS level 2 device profile, we have determined with regard to the bit timing that we are using the 50 kilobits, so the amount of data to be transferred is not that much. So therefore, the SIIS level 2 group opted for this data rate. Optional, I can also support the 125 kilobit. With regard to the transceivers, we know that the automotive industry is no longer using the fault-tolerant transceiver, and therefore it's a little bit a question of long-term availability. So for the moment, this industry is using the fault-tolerant transceiver, but maybe in the future they will have to switch over to the high-speed transceiver because the fault-tolerant transceiver is no longer available. And therefore, they have written also in the document CiA 443 that in future there may be a switch to the high-speed transceiver if it's no longer available. Also, with regard to the connector pin assignment, we have a definition in CiA 443. I don't want to bother you with this. And this pin assignment is also in a recommended practice available, the 13628-6. So the SIIS group has submitted also the information that they gathered in our working group into recommended practice that had been standardized at ISO. You see the number on this slide. Also to the lower layers, you can consider the task in CANopen networks that you have to assign a node ID, a unique number for every CANopen device, 7-bit coded. And in Subsea instrument applications, you are forced to support the so-called layer setting services. So CANopen gives you a degree of freedom how you like to assign the node ID to your devices. In Subsea applications, you have to support the so-called layer setting services. This means a central host controller detects which devices are available, and to these devices, the host controller hands over the new node ID value that shall be applied, and then the device can start up into the system. So briefly to layer setting services. Layer setting services allow you to identify whether there are unconfigured LSS devices available in your system. They allow you to differentiate between them. They allow you to hand over a new node ID value, and they allow you to switch from one bitrate to another. So this is also supported in the Subsea devices typically, but I like to warn you doing the bitrate switching via LSS. Here, I think it is much more recommended to use automatic bitrate detection, as if one device in the Subsea instrument listen to the bitrate switching command, you will end up in a mess. Therefore, this is something for the laboratory. What is working really good is an assignment of node IDs, the switching of node IDs via LSS. And as I said, this is mandatory for Subsea devices. Coming up one layer higher to the data link layer for 443-based devices, and this is just CAN. And you may know in CAN, you may have the base frame format and the extended frame format. Now we have also a CANFD based frame format, and maybe in future a CANXL frame format. But here we are talking about classical CAN, and we are using those frames with the 11-bit CAN identifier, the so-called base frame format. And we avoid the usage of remote frames because remote frames are a little bit tricky. So there is a certain probability that they cause fault operations in your application because your application has not updated the memory yet, and your CAN controller is communicating something what's occasionally in the memories if it's requested from outside via remote frames. So therefore, briefly, we just don't use them. So forget about remote frames. We are just using data frames, as remote frames are just one mean to trigger data. And we will see in Subsea instrument application CiA 443, we have other means as well. So there's no need for using remote frames. And we are using now this data link layer, the classical CAN data frames, for communicating our CANopen data. Briefly to CANopen. CANopen has been pre-developed in a European research project, ASPIC, in 1993, and the results have been handed over to CAN Automation, the CAN-based application layer-based communication profile in the version 1.0. So very short after this, we provided the public already with a second version, 2.0. We updated the document and removed the complex name and substituted by a shorter name, maybe more practicable via the name CANopen. And CANopen was submitted for international standardization on the European level. It's now available as EN 5325-4. And at CAN Automation Office itself, we continued working with the document, and the public available version is now the version 4.2, which you can download from CAN Automation's website. And as I've already mentioned, CANopen had been updated with regard to CANFD. The result was the CANopen FD in the document CiA 1301, the version 1.0. Let's have a brief look. What is CANopen providing? CANopen provides us with a device model. Every CANopen device has the internal device structure you see here. We have a piece of software controlling the CAN interface of the device. And if this piece of software controls the CAN not just somehow, but in the way it is described in the CANopen specification, then this is called the CANopen protocol stack, providing services for data exchange, the PDO and the SDO, and they are services that are more or less related to network management. How can I achieve a synchronous network behavior? How can I set a unique network time? How can I communicate diagnostic data with the emergency? Or how can I switch my device in a certain network state where I can configure the device, run the device, or logically disconnect the device from the network? I have another piece of software, which is typically the core competence of the device manufacturer, the application software, controlling the real device functionality. And to allow both software entities to exchange data, how to bring, for example, sensor values generated in the application software to the CAN, then we have an internal interface, an internal database. It's the so-called object dictionary. And the object dictionary provides all parameters that describe the behavior of my CANopen device at the CAN, the so-called communication devices. So when do we like to communicate something? Which CAN identifier do we use? What is the data content? And we describe here all the application parameters, define application behavior of my device. We can either in a proprietary way or in a standardized way. And we are in the use case of the standardized parameters with CiA 443. CiA 443 defines us a set of data, of application data, that allows us to control Subsea instrument functionality, Subsea instrument applications. So we are focusing now a little bit on the object dictionary. So this is the object dictionary layout. All the data is referenced via a 16-bit index. So we see this here. This is the 4-digit hexadecimal address. And we have one index range 6000, where we have the standardized parameters, for example, standardized in CiA 443. And another very important area is the index range 1000, where we have our communication parameters. Let's have a brief look. We have now an index 1000, and the index 1000 indicates which profile is implemented. In our use case, it's 443. And the additional information provides us which functionality defined in CiA 443 is implemented in fact. And we see here which kind of functionality do we consider in 443. The pressure sensor, temperature sensor, inclinometer, multi-phase flow meter, wet gas meter, sand meter, oil meter, and so on. And as we have too many functionalities to indicate all of them in these 16-bit, we have an extended representation. We have an additional object 6000, where we can also indicate that we have rotational position sensors, digital inputs, corrosion sensor, and so on. So this is the functionality defined currently by CiA 443. And you can go now and say, okay, I just want to implement the temperature sensor. So I just set bit 17 here, right, that I have 443, and I'm fine with this parameter. And everybody who reads this sees, okay, this is my temperature sensor implemented for subsea applications according to 443. So also for the communication behavior, CiA 443 gives us a lot of useful information. So for example, the information, do we using the sync message? Yes, all the devices by default shall come as a consumer, and we expect the CAN identifier 80 hex for the sync message. We shall support the manufacturer device name, hardware, software version, that we can recognize all the devices. We shall support some non-volatile memory, that we have the ability to store information or configurations and to restore the default parameters. We shall support the emergency service, so that we can have that subsea devices have the ability to provide diagnostic data in case of an emergency. A host controller shall have the ability to monitor its devices. Therefore, the producer heartbeat shall be supported by all the devices, and the consumer heartbeat depends, and devices may monitor other devices as heartbeat consumer may be supported. Identity is anyway mandatory for every CANopen device. And we see here, this level 2 devices support the bootloader mode. Therefore, they support program download as it is specified in the document CiA 302. You remember, one additional document extending the basic CANopen functionality. And in addition, to clarify and fine-tune the CANopen communication capabilities, CANopen CiA 443 defines also application-specific data, general device parameters, data for sensors and actuators. So we see this here. We find here, for example, the way how to provide pressure values, temperature values, linear positions, rotational positions, inclinations, analog and digital input and output values. And complex device like the multi-phase flow meter, oil gas monitor, the vibration monitor, corrosion data set, and time a very specific data type. So this data type we will see on the next slide how it works. We have here the pure process value given as a float value, real 32. And then we have, in addition to this, the SI unit in a standardized format, that we have the prefix, the SI unit, nominator, denominator, and we have then the status of the sensor. Is the sensor, for example, currently in a self-testing mode? Is the sensor okay, or is it currently in trouble? And furthermore, for analog values, it's sometimes a little bit difficult to find the right trigger event. When do we like to report that we have real new data? So only if the data has changed via a certain delta, and the delta may be in a different value. If it's in a negative way or in a positive way, maybe I have to react faster if the value is rising than if it's falling. So I can provide this information or make my pre-adjustments in the sensor and then consider all this information by operating the device in subsea instrument applications. So you see, we find a lot of pre-adjustments in CiA 443, on the one hand for the networking, on the other hand for the application data. To communicate all this data, we are using CANopen, the basic CANopen protocol, and we see this here. CANopen communication services. Typically, a CANopen average device has to support the expedited SDO protocol. This level 2 devices have also to support the segmented transfer. This is because this level 2 devices support firmware download and the firmware update. So therefore, at least the segmented transfer is an obligation. Block transfer is completely optional. We have to support the PDOs. The PDOs defined for the certain device class for the supported functionality defined by CiA 443. We have to support the sync mechanism. We have to support the diagnostic data reporting, the emergency service, and of course, the network management and the monitoring service. Briefly, we see here how an SDO works. The SDO is a confirmed communication between two network participants. That device that is initiating the communication is called the client. The client wants to read or write something in the server, and the server provides the answer. So one confirmed one-to-one session between an SDO client and an SDO server. And in this communication, we can exchange here if the data is very small, not larger than 4 bytes, which is typical in a CANopen environment. We can provide the data directly during the initiation. You see here the write access or the read access, and in both cases, directly during initiation, you transfer the data. This is expedited transfer. The segmented transfer we see here. We have here also the initiation. The client once again initiates. The download indicates optional the length of the data to be exchanged. Where do we write in the server's object dictionary? And then we get the confirmation, okay. And we establish a kind of ping pong game where we say, here's my next segment. Okay, I've received it. Please send me the next segment till we indicate in our command specifier, this is the last segment, and we get the confirmation. And also this normal transfer, which is optional for average CANopen devices, is met here for this level 2 devices. We have to support the CANopen PDOs. The PDOs as defined in CiA 443 specific for a certain functionality. And a PDO uses one single CAN frame, puts it full of data, and so that the consumers can recognize which CAN frame shall be considered as a PDO and where shall I store the pieces of my data in my local object dictionary. I have huge mapping tables. One PDO consists of 2 parameters how this PDO shall work. So the communication parameters and the mapping parameters. The communication parameters say which is the CAN identifier, what is the triggering event, and the mapping parameters say which data content shall be transferred out of the local object dictionary, or for received PDOs, how to structure the received data and where to store the pieces in my local object dictionary. So you see here one small example for a received PDO that we say, oh, there comes a message with a CAN identifier 181, 4 byte of data, 21A40803. I have no idea what I shall do with this, but then I recognize, oh, here in the communication parameters, I find my CAN identifier 181. So I know this message is considered as first received PDO of my local configuration. The first received PDO has here its mapping parameters. So take the first 8-bit and store them to 2000 subindex 1. This is a temperature value. Take the next 2 bytes, store them to 2003 subindex 3. Oh, this is a depth value in millimeter. And finally, take the last byte and store it to 2003 subindex 1. Oh, this is an height value in millimeter. So I see as soon as I have the mapping table, I know how to interpret a PDO, and in the very same way it works for the transmit direction. The mapping table indicates then which data out of the local object dictionary shall be transferred, and the communication parameters indicate which CAN identifier is used. And these PDO definitions are done for the corresponding functions, where to transmit my pressure value, where to transmit my temperature value, where to transmit the combined information, this is everything predefined. How to use it if I use PDO communication. If I have several metering channels, then I have a default mapping and I can provide, according to the standard, my process data. And as I have now predefined process data and process data communication, which can identify as used what is the structure of my process data in the CAN frame, I increase the degree of plug-and-play functionality of these devices in Subsea instrument applications, and thus I reduce the effort of system configuration. So we see here for the corrosion sensor, more complex data. I communicate here the metal loss, and see here that we have predefined PDOs also for this. And for the chemical injection valve, we see that we are using something that is called a turnaround PDO. I sent from our application master perspective a control word and the set point for the position, for the flow, and the chemical injection valve automatically informs me on the current status, on the current position, on the actual flow. So all this is predefined for the device, and as I know this chemical injection valve is following CiA 443, I don't have to pre-configure anything because everything is predefined and I can rely on this and just use it and have a high degree on plug-and-play functionality. As I said, the emergency protocol has to be supported, so the SIIS level 2 devices can automatically inform the host controller what's going on. Is there something strange going on? Is there some countermeasure required? So this we can inform here. And of course, such as every CANopen device, we have to support the network management state machine, where we can switch a device in an initialization state, in a pre-operational state to configure the devices, in an operational state to run the devices, or in a state where I logically disconnect the devices from the network so that I can have them available in a kind of redundant situation. So I have these device states, I have to support them, and via the network management error control protocols, I monitor whether all the devices are still available and whether they are in the correct network state. So the CiA 443 mainly has in focus the end device, the simple device, the simple sensor device, but CiA 443 considers also somehow the SIIS level 2 host controller. So the host controller is a central device that provides or that has access to all these SIIS level 2 instruments, and this access is done via SDO. Therefore, the so-called SDO client resides here to all the other devices. That is, access is available to all the object dictionaries, to all data element available in this SIIS level 2 application. This SIIS level 2 controller receives process data generated by all the instruments and provides commands if they are needed to the instruments. And this SIIS level 2 controller controls and supervises the instruments by means of network management and heartbeat, and receives also the emergencies to start appropriate countermeasures. It's also the functionality available that there's a redundant SIIS level 2 controller available. So then it is recommended to use a so-called flying master functionality, which is also described in CiA 302. We have also heard that the instruments are using LSS for getting the node IDs. So the master application who assigns the node IDs resides in the SIIS level 2 controller. If we are talking about system startup, then we have also to consider that the devices typically go into the bootloader mode and expect that someone is downloading them, the current firmware. And then if the firmware download was successful, then the devices start up in the operating mode. So although this is considered, how this works, it goes in a lot of details. So, but it's described in 443 and then referenced also to 302, which describes the bootloader handling. Yeah, so much for the moment from my side. So CiA 443 is CAN and CANopen based. CAN and CANopen toolchain is available from several sources. So the CiA 443 is not too much new. If you are already familiar with CAN and CANopen, you can say, okay, it's just the way how we use the functionalities provided by CAN CANopen in a CiA 443 environment and a SIIS level 2 application. And except of the fact that you need an adapter for converting from ISO 11898-2 to 3, you can use the available toolchain. Then CiA 443 enables interoperability of devices or even entire subsystems. So as we have defined interfaces to the rest of the system, and we from time to time we have these plug fests. I think there can be also some SIS plug fests again in the future. They increase, of course, the reliability of the devices, shorten configuration efforts, as we are sure that all have the same way of interpreting CiA 443. And the group, which has restarted its activities, the special interest group Subsea, maintains and enhances CiA 443. And therefore, my strong invitation, come to CAN and Automation, ask that you like to join one of the next meetings as a guest. So I think there is no problem, and especially that next meeting that will take place during the ICC, the International CAN Conference. It's an open meeting where we once again explain a little bit why it is reasonable to have and maintain and further develop CiA 443. So if you have additional feature requests, you can come to CAN and Automation, submit them, and we will consider them in this group. When the group is meeting and what are the next steps, you will see on our webpage, can-cia.org/group/technical groups. Just scan for the Subsea group, and then you will find some details. Otherwise, just email me, and I will provide you with some additional details. If you want to receive regular information about CAN and Automation and about CAN, then you have the availability of the CAN info mail and the CiA member news, where we provide this. Just register on CiA webpage or write us an email that you like to receive it. When times of Corona pandemic are over, they have also the ability to meet us, or the possibility to meet us on fairs. You see here which fairs CAN and Automation is planning to attend in the next years. And of course, we will continue our webinars. You see here the listing of CAN Automation webinars, not only in English, but also in Chinese or Russian language. This you see here on this web page, or on the homepage from CAN and Automation, www.can-cia.org. So I don't see any further questions here. So if they come afterwards, or when you dig in deeper in the Subsea project, please feel free to contact us, follow us on social media, and write your questions, and we will try to assist you. Then I stay and hope in one of the CAN Automation events, maybe also on the International CAN Conference. Once again, I like to remind you, as you can see here, on the 14th to 17th June 2021 International CAN Conference, where experts discuss latest developments in CAN, such as CAN XL and CAN FD. Thank you very much. Have a great day. Bye.